Good afternoon, ladies and gentlemen. Today I want to go through a question which prompts us to find the initial velocity of a projectile that traveled 90 meters that was thrown in the air at an angle of theta of 45 degrees. So to visualize this, I set up this little vector diagram, I guess, and we need to find this spot. This is denoted as VI. This is the initial velocity at which the projectile is thrown. We know the angle here is theta, and since we are on a xy plane, we can denote these as the velocity of the initial velocity on y, and v, and the initial velocity on x. We know that the projectile goes in a travels in a trajectory, and we know that the distance traveled is 90 meters. So we can denote this as delta x. There's a point at the top of the trajectory at which the velocity, the final velocity of y, so the f, so we can say vfy is equal to 0. So in that sense, we also know that the time of the projectile traveled at this point is t divided by 2. So we're essentially cutting the projectile motion problem into two, so that we don't have to deal with negative acceleration and negative velocity, and can just figure out the initial velocity at this using this part of the movement. So now, how do we actually set up the solution? So we are trying to find VI. We know that delta x can be represented in the form of v of x, so the initial velocity of x times time. So conversely, we can denote v of x as delta x, divided by time. So we know these aspects of it. We also know that since we are using, since this is all happening using an x and a y plane and an angular, and has an angular component, that we can also denote these using sine and cosine. So we can denote v of I of x as vi times cosine theta, and similarly we can also do v of y, the vi of y as vi times sine. As sine theta. So now that we know these, we can also see here, since v of I of x is equal to delta x over t, that this is also equal to v of I times cosine theta. So we can basically equate these three components. Then we have to further set up more aspects of our equation. So let me go. Oh, I don't think I can. Can I go down? Oops. Wow. Okay, so I mean, I'll just go on a new page. So, what else do we need to consider? So, furthermore, we need to consider acceleration. So we know that acceleration can be denoted is in this case gravity which can be additionally denoted as the change in velocity over the change in time. So delta V and delta T. We can rearrange this equation to make delta V equal to G times T over 2, since delta T is T over 2, since we're only looking at one side of the trajectory. So having this, we also know that delta V, this is not delta V, this is delta V and Y. So we also know that delta V and Y is equal to the initial velocity times sine theta. So we can rewrite this as VI sine theta equals G times T over 2. And furthermore, if you remember, we also know that Vi of x is equal to Vi cos theta, equal to the change in time. Not the change in time, the change in x over time. So delta x over time. So now that we know these, we also know that time can be rewritten as delta t equals delta x over Vi cosine theta. Cosine theta. So by using this equality, we can plug this into this equation and we get Vi sine theta equals G over 2 times delta x Vi cos theta. So now we want to set up a situation where we can solve for Vi. We can do this by saying that Vi squared sine theta equals G times delta x, G times delta x over 2 cos theta, which can be rewritten into the square root of Vi squared equals the square root of G times delta x over 2 cosine theta sine theta. So this is the final equation which we get, with which we can finally plug in our given values right here to answer the question for Vi. So we do is, in this case, Vi would equal to, we know that gravity is equal to to simplify the question, we can just use gravity equal to 10. We can also use gravity equal to 9.81, but for the sake of simplicity, I'll just do 10. So we know that 10 times delta x, which we are given, is 90 over 2 cos. I don't know if you've noticed, but I'm having intense troubles drawing out the cos and the sine, and generally every single letter and number, and I apologize. But we can denote VI, we can solve for VI by setting it equal to this equation. And if we plug this into the calculator, we get VI equals square root of 900, which is 30. So we know that the initial velocity is 30 meters per second squared. And we did this just by setting up an equation for VI with sine and cosine and time and the distance between things. Thank you very much for listening. Have a great day.